NVIDIA designs some of the world's most powerful AI chips. Apple designs the chips inside its iPhones and Macs. AMD designs processors used in computers and data centers. But here's the strange part. These companies don't manufacture many of their most advanced chips themselves. Instead, they depend on a company thousands of miles away, in Taiwan, TSMC. And today, this company sits at the center of the AI revolution because designing an advanced chip is incredibly difficult. But actually, manufacturing millions of them at microscopic scale can be even harder. So how did a Taiwanese company become one of the most important manufacturers on Earth? And why are governments now spending billions trying to reduce their dependence on it? Chapter 1. The brilliant idea behind TSMC. To understand TSMC, you need to understand one idea, the foundry model. For decades, semiconductor companies often designed and manufactured their own chips. But building semiconductor factories is brutally expensive. A modern advanced chip factory can require investments measured in the tens of billions of dollars, and the equipment inside is some of the most sophisticated machinery humans have ever built. TSMC took a different approach. Instead of competing with customers by designing its own mainstream consumer processors, it focused on manufacturing chips designed by other companies. Think of it like this. NVIDIA creates the blueprint, TSMC builds the product, Apple designs the chip, TSMC manufactures it. This separation created an entirely different semiconductor industry. Companies could focus enormous resources on designing better chips without needing to build cutting-edge factories themselves, and TSMC could focus on one thing, becoming extraordinarily good at manufacturing them over time. That created a powerful cycle. More customers brought more production brought more experience. More experience helped TSMC improve its manufacturing processes, and better manufacturing attracted even more customers. But then something happened that made this business dramatically more important. Artificial intelligence. Chapter 2. The AI Gold Rush. When ChatGPT helped ignite the generative AI boom, investors immediately started looking for winners. NVIDIA became the obvious one. Its GPUs became essential infrastructure for training and running many advanced AI systems. But every NVIDIA chip has to exist physically. AI models don't run on stock prices. They run inside data centers filled with real processors, and those processors have to be manufactured somewhere. That's where TSMC enters the story. As demand for increasingly powerful AI accelerators exploded, demand for advanced semiconductor manufacturing became even more strategically important. This is why the AI boom isn't simply a software story, it's also a manufacturing story. Data centers need GPUs. GPUs need advanced semiconductor manufacturing. Advanced chips need sophisticated packaging. Factories need enormous amounts of equipment, electricity, water, and highly specialized engineering. So while investors were watching AI companies fight for customers, another battle was happening underneath them. Who can actually manufacture the chips? And at the leading edge, there aren't many companies capable of competing. Chapter 3. Why this is so hard. Here's what makes TSMC's position so difficult to replicate. Modern chips contain billions of transistors, and those transistors are manufactured at dimensions measured in nanometers. At this scale, tiny imperfections can destroy a chip. Manufacturing isn't simply about owning an expensive machine, it's about learning how to make enormous numbers of chips with consistently high yields. If too many chips on a wafer are defective, production becomes dramatically more expensive, and this creates something investors sometimes underestimate. Experience matters. A competitor can't simply spend $20 billion, build a factory, and instantly become TSMC. It needs equipment, engineers, suppliers, processes, customers, and years of manufacturing knowledge. This is why semiconductor manufacturing has become one of the largest technological barriers to entry in the world. But TSMC's greatest advantage is also connected to its greatest risk, because much of the company's most important manufacturing capability has historically been concentrated in one place, Taiwan. Chapter 4. The Taiwan Risk. And this is where TSMC becomes more than a technology company, it becomes a geopolitical story. Taiwan sits at the center of one of the most sensitive relationships in the world. China considers Taiwan part of its territory. The United States maintains deep economic and strategic interests in the region, and right in the middle of that tension sits some of the world's most important semiconductor manufacturing capacity. Think about what that means. Smartphones, AI servers, data centers, cars, cloud computing, defense systems, entire industries depend on advanced chips. A serious disruption in Taiwan wouldn't simply affect TSMC shareholders, it could affect technology supply chains around the world, and governments know it. That's one reason semiconductor manufacturing is increasingly being treated as strategic infrastructure. The United States, Japan, Europe, and other economies are investing heavily to expand domestic chip production, and TSMC itself has been expanding manufacturing outside Taiwan, including major investments in the United States and Japan. The goal isn't necessarily to replace Taiwan. That's extraordinarily difficult. It's to reduce the risk of having so much critical manufacturing concentrated in one location. And that brings us to the strange position TSMC occupies today. Its importance is one of its greatest strengths and one of its greatest risks. Chapter 5. Can anyone catch TSMC? Of course, TSMC isn't alone. Samsung is investing heavily in advanced semiconductor manufacturing. Intel is trying to rebuild its manufacturing leadership and expand its foundry business. Governments are pouring enormous amounts of money into semiconductor production. But money alone doesn't guarantee success. Because the real competition isn't simply about building factories, it's about manufacturing advanced chips at scale with high yields at the right cost and delivering them reliably to some of the most demanding technology companies in the world. That's why catching TSMC is so difficult, but it's also why competition matters. If Samsung or Intel significantly improves its manufacturing capabilities, customers could gain alternatives, and TSMC's extraordinary position could become less dominant. So the moat is enormous, but it isn't permanent. Chapter 6. The investment case. So what does an investor actually see when looking at TSMC? The bull case is straightforward. AI needs more computing power. More computing power requires more advanced chips, and many of the companies designing those chips need someone capable of manufacturing them. TSMC sits directly in that chain. It doesn't need to predict whether the next dominant AI application will come from OpenAI, Google, Meta, or another company entirely. If the computing race continues, the demand for advanced semiconductor manufacturing can continue with it. In that sense, TSMC resembles one of the oldest strategies from a gold rush. Don't search for gold, sell the tools to the miners. But there are risks. Semiconductors are cyclical. Factories require enormous capital investment. Competition is real. Customers like Apple and Nvidia are extremely powerful. And above everything, there is Taiwan. That geopolitical risk is impossible to completely remove from the investment thesis. The factory behind the future. The most famous companies in artificial intelligence may be Nvidia, Microsoft, Google, and OpenAI. But underneath the software, there is hardware. Underneath the hardware, there are chips. And behind many of the world's most advanced chips, there is TSMC. That's what makes this company so unusual. Most consumers will never buy a TSMC product. They may never even see its logo, but every time they use an advanced smartphone, a powerful computer, or an AI service running inside a data center, they may be much closer to TSMC than they realize. Because in the AI gold rush, everyone wants to find the gold. TSMC helps build the shovels.